What is light? Does anybody really know? I didn't really know what light was. Is light a particle? Is light matter? Well, actually, light is both. And today, we'll talk a little bit about how we came to that knowledge of what light is. For my article, my topic today, I went and visited a lot of different articles and websites to understand and learn more about what my topic was, as well as using some of my past knowledge of the topic. So today I want to talk to you guys about spectroscopy. And I'm going to be focusing on two specific topics of spectroscopy. The first one is, what is spectroscopy? The second is how spectroscopy works. And so we'll dive right into what is spectroscopy. So my first thing talks about spectroscopy is a quote from Jack D. Graybill from his article in the Encyclopedia Britannica. He tells us that spectroscopy is the study of absorption and emission of light and radiation from matter related to the process of wavelengths. The definition has also been expanded to the study of the interactions between particles such as protons, ions, and neutrons. There's a lot of crazy words in that definition if you just read it, not really knowing what it was. And so, to break down a couple of those terms, I used Wikipedia to kind of break it down basically. So the first one I wanted to talk about was absorption. What is absorption? Absorption is when light hits an object with no light, such as light from your flashlight hitting a black truck or a black object. The light just gets absorbed into it. The second one is emission. What's emission? Emission is not from a gas tank, from a car. Emission is what a star emits, those wavelengths that comes from the star or the object. Radiation is obviously not a good thing. Radiation is high powerful wavelengths. And particles are what matter is made of, and protons, neutrons, and ions are what that particle is made of. And those definitions once again came from Wikipedia. So, once again, what is spectroscopy? Spectroscopy is a study of light when it hits an object, and then it either absorbs it or it's being emitted from a different object. And so they use spectroscopy to study the light from a star or an object like a planet in the atmosphere or in the galaxies, and then they can know more about that star or object. And they can also analyze white light by distributing it through a prism. And so if you look at my first picture on the PowerPoint, you'll see kind of the first stage of what spectroscopy is, and that picture is from K or D. Kuru on the Wikipedia website on spectroscopy. So spectroscopy can be used for a lot of different things that you might not even think about. Astronomers can use it to view spectral lines and to see other spectral lines and know known elements to learn about the chemical composition of certain objects. They also use it to study the motion of an object moving closer or farther away. Those terms would be called blue shift and red shift. They also can use spectroscopy to study how the galaxy moves, to find stars, to find planets. And so to talk a little bit about some of those terms, blue shift, red shift, wavelengths, what are those? So a wavelength, if you look at the ocean and you see a bunch of waves, what you can do is, you see one crest wave and then another crest wave. If you measure between the two waves, then you get a wavelength, and that's how they determine what a wavelength is measuring the crest of each wave. Blue shift. What's blue shift? Well, blue shift is when an object is moving closer to you, so the wavelength from that object or star is blue. If that object is moving away from you, then the wavelengths of that star will show red. So if you look at the second picture on that PowerPoint, that's one view of the wavelengths of our sun. It's kind of a cool little view of all the colors that are emitted in one wavelength from the sun. So now that we know a little bit about what spectroscopy is, let's talk about a little bit how it works. So when a substance is very hot, it will emit light at all wavelengths in a continuous spectrum. If it passes through a gas cloud, it will be absorbed, and then it'll absorb specific atoms of those wavelengths, and then it'll move on. The rest of it will move on or move through. In this, astronomers can observe the line spectrum waves of certain wavelengths, and then they can use it to see what those wavelengths are, and then they can also use it to study objects in the celestial that does not have light. And so when they're using it to study an object of light, then they look at the continuous line spectrum, and when they use it to study an object with no light, it's called emission line spectrum. And that's from the Los Cumbres Observatory. So a continuous spectrum line is basically light from a star continually hitting another object, and that object absorbing it. And then an emission line spectrum is from an object that has no light. It's just emitting the wavelengths. And so the astronomers can use spectroscopy to study either the light from the star or the wavelengths from an object that doesn't have a star. And that's from Cosmos website. Astronomers can also use it to fingerprint the stars by breaking apart its component colors by passing it through a prism, and then they can view on what the chemical background is. And so if you look at the third picture on the PowerPoint, it has a picture of a sun, then an object that it hits, and then it passes through the prism, and as it passes through the prism and it hits a black object, you'll be able to see what light or color it absorbs. So those are pretty cool. So in conclusion, we talked a little bit today about what spectroscopy is, that it's a study of light from an object or from an object with no light by using prisms and other things. And it can be used to study motion of the galaxies, of stars, finding planets. And so I really hope that you guys learned something today, and have a good day.